I'm doing shortest path in binary matrix. It's a Leetcode number 1091, medium problem in C++. So given a square binary matrix grid, return the length of the shortest clear path. For context here, the shortest clear path is any 8 direction connected path, whereupon every value in the path is 0. So in this case, this is 2 because this is connected diagonally, starts at 0, 0, which it always does, ends at n-1, n-1, where n is the size of the matrix, as it does here at 0, and it's a length of 2. So the way I'm thinking to do this is when I see shortest and matrix in the same sentence, my brain almost always thinks, and it should in this case, breadth first search, because breadth first search will guarantee you, if a path exists, the shortest path or the shortest value of the path, or whatever the shortest you need, the shortest it will give. So let's first look with breadth first search in a matrix. We effectively want to consider all different possible directions we can go from a point. So that's horizontally, vertically, and diagonally. So let's first create a list or a vector of possible spots that we can go in at any point. So possible directions. So we can go across, we can go backwards across, we can go up, we can go down, we can go diagonally up, we can go diagonally bottom right, we can actually we're going up and left, so not that. We're going to be going -1 here, and we got what have I not done? -1 and 1. So we have 8 possible directions total. We then want to get the size of the grid. We know it's a square matrix, so I can make this assumption that grid is not the same as one row in size, and they're the same thing. So n is grid size, just a shorter way of explaining it. So in our constraints, it doesn't say that the first spot or the last spot won't be 1. So we basically want to get rid of this edge case now. So if grid 0, 0 is not equal to 0, or grid n-1, n-1 is not equal to 0, then we want to return -1. We don't even want to bother with the search because we know that there isn't a path here. Otherwise, we have a guaranteed path or we have the start of a path because we know that the values have to be 0. Because if this is 0, it will check if this is 0, for instance, and if neither of them are 0 or one of them isn't 0, then we don't have a path. Otherwise, we now check for our path. So we want to have a standard queue of coordinates here for breadth first search. We push in 0. We want to set the value of the start point to be equal to our current path size. And at every point in our search, we will update the next spot with the path value +1. This way we're storing the values, and we know that by the time we get to the end spot, we'll have already computed its distance. So that way we've updated the distance and we can just return it straight out here. So we now check. So while the queue is not empty, we look at our spot. So pair our current coordinates, which is equal to q.front. We then pop the coordinates from the queue. Let's just define some variables here. So our row is going to be equal to current coords.first. Int column is going to be equal to current coords.second. Now let's check, have we reached the end? So if row is equal to n-1 and column is equal to n-1, then we've reached the end, and we can just return. Let's actually get the value of the distance spot at that point as well, which is going to be equal to grid at row column. If we reach the end, we can just return distance. We've already updated the value at this spot when we were adding new spots to the queue with distance +1, which means that our final value will be the final distance. Otherwise, if we've broken out here, then we know that we've not reached the end yet, so let's go through all the possible directions that we can go in. Possible directions. We want to first get int dr is equal to d dot first, int dc is equal to d dot second, int new row is going to be equal to row plus dr, int column is going to be equal to new column is going to be equal to column plus new distance in column, difference in column. Now we check for any of these new spots that we've generated in the 8 directions that we've gone in. Firstly, are we within bounds? So is our row less than the maximum, and is it greater than 0? Greater than 0. So we're within the row boundaries. Are we also within the column boundaries as well? So same thing, because it's a square matrix. Okay, and if we're within boundaries, let's also check, are we actually at a spot that we can consider? So is the new row, new column spot equal to 0? If it is, we want to add that spot to our queue. New row, new column, and we also want to update its value as well. So grid, new row, new column will be equal to distance +1. If we've broken out here, we just return -1. So let's run the code. And let's submit our code.